I finished 10 minutes before today, it's fine. So I'm going to talk to you about something called iceperf.com. So before that, my clicker isn't working. There we go. So a little bit about me first. So yes, I'm Dan Jenkins. I'm the founder of a company called Everycast Labs, NimbleApe, and I am also the creator of ComCon. ComCon is a conference in the UK. I was the very first Google developer expert in WebRTC, and this was a little while ago now. I'm no longer a Google developer expert because things take over, but yeah, I can say forevermore that I was the first. I love Lego, although I used to love Lego before I had kids, and now I don't get any time for Lego. I also love real-time media, and especially building things for the web. The web is really special to me. It's where I kind of started my career. And yeah, I've now been in open source real-time media for over 10 years. And that is how, those three are how you can contact me. So yeah, NimbleApe, we're a real-time media consultancy. We're sponsoring this conference. We're based in the UK, and we do anything media-related, but especially real-time media. Everycast Labs, we've got a product that brings in remote talent, as people like to call it in that industry, into AV workflows. So being able to bring someone in and output them in NDI or SDI or SRT, etc., and put them into the right format for the right thing. And then, yeah, ComCon, open media. It used to be a real-time conference, and then all the lines started blurring as to what was real-time, what was not, what were people working on. And so now it's an open media conference. If you Google open media, it won't be what you think it is, but it's real-time media. It's non-real-time media. It's traditional media delivery. And there's 6 years worth of content on our YouTube channel. So hopefully soon we'll have a rebrand of the ComCon website that will make finding video far easier. But today, iceperf.com. So taking iceperf.com to the next level. Who in the room has heard of iceperf.com? Oh, that's more than I thought. That's great. So what is iceperf.com? So ultimately, ICE is a vital part of WebRTC. It's how we make those connections between two peers. A peer, don't forget that a peer can be a server, a peer can be a device, can be a web browser. And so stun and turn are vital parts of that process. Does everyone know what stun is? Who doesn't know what stun is? Don't be scared. That's fine. So stun is our way of figuring out what my public routable IP and port is. It's basically me saying, oi, server up in the cloud, I'm going to route some traffic to you, and you're going to tell me, well, you came in on this port, and this is how someone else can kind of piggyback into you and make a connection. So what's turn? So turn is very similar, but also very different. Turn is where we say, oi, same server, possibly, or very different server, possibly. I want to send my traffic through you. How can I do that? Go give me the IP address and the port that I need to route traffic to. So ICE impacts how WebRTC peer connections are set up. And so you can see why delays in that process slow down everything. If you're making calls, sessions, whatever, via a WebRTC peer connection, then if that is half a second delayed, well, that's half a second that you're not talking to someone. And so we do lots of tricks to try and speed all of this up. But ultimately, if your stun server is slow, if your turn server is slow, then that's going to impact performance. So what public data is there about the performance of these stun servers and these turn servers? I should have gone and got a list. There's a list in a gist, in a GitHub gist somewhere. There's a list of loads of public stun servers. I should have gone and got it. How do we know how they all perform? Well, the answer is we don't. There's no public data available for any of it. Enter iceperf.com. So we wanted to test turn networks. That's our first kind of foray into this. But as the name suggests, ICE is used for lots of other things as well. And so we won't just be stopping at turn networks. We'll be moving on to other things as well. So what does iceperf actually do? Dan, you're like 5 minutes into this and we don't actually know what iceperf does yet. So what does it do and how does it do it? So firstly, the what. So we test the turn network abilities. And we also test the Google Stun server because everyone uses the Google Stun server at some point. Some people forget to take it out of their production code. Or some people actually leave it in thinking, oh, that's a great idea. I'll come on to why that's a bad idea later. So we also test open source turn servers as well. So Software Mansion have a project called RHEL, and they host a version of it, and we test it. So thank you very much to Software Mansion for hosting that RHEL server and giving us access to it. So the turn networks, who are they? Twilio, Xersys, Cloudflare, Metered, and Express Turn. So yeah, for a very, very, very long time, we had Twilio and we had Xersys, and those were really the only options available to us. Then a couple of years ago, there was a company called Subspace, and Subspace came in and they had a turn network as well, but unfortunately they collapsed and left Twilio and Xersys again. Having a choice of two isn't a very good choice, and so lots of people would say, well, why don't I just run my own or whatever. But now we've got 5. So Cloudflare entered the race. Metered and Express Turn also entered the race. I don't know when Metered and Express Turn did. It was actually Cloudflare entering that made us want to test and go, right, we're giving this advice to our clients, like you should go and use Twilio's turn network. Are we actually giving the right advice anymore? That's what led us to kind of building iceperf.com. So yeah, Cloudflare entered the race, and that's what started iceperf. So initially, iceperf.com got launched at JanusCon, however many months ago that is now, and it tested 3 things. So it tested time to receive a candidate, stun and turn candidates. It tested the latency to go through that turn server, and then it also tested the throughput of that turn server. And the way that we test it is we have one Golang process, it's using Pion, and it creates 2 peer connections, and one of them is told, right, go out via this turn server, and the other one receives it back from that turn server. Yeah, those peer connections are started up with one ICE server URI in its instantiation, which is very different to how we would do it normally when we're setting up a WebRTC peer connection. Normally, you would say, here's my stun server, and here's my turn, maybe over UDP, here's my turn over maybe TLS, right? We'd give those 3, but we test each one individually. So turn tests force that ICE transport policy as part of WebRTC, and we tell it to use relay. And yeah, like I say, it goes out and then comes back in. It's one big loop. And all the tests are done via my home, well, not via my home broadband connection. They used to be done via my home broadband connection, but now they're done by a group of home broadband connections. Why not put it in a cloud somewhere, on a server somewhere? Well, clouds have nice peering with one another, which then makes things super snappy. We actually want to test, like, you know, last mile copper and last mile fiber and everything else. That was then. So that's what we launched with. And this is now. So what have we actually been up to? So we've now got real-time data access. When we launched, it was all like copy and pasted values into a website and like screenshots of graphs out of Grafana. Now we've got real-time data. We've now got interactive graphs as well. And we've got better reporting on transfers. So what I mean by that is we use the WebRTC statistics to know how much data was transferred instead of us counting. Did we get it wrong? I don't think so, but this way we're looking at, you know, the same metrics that everyone else is. And then we also now report on both average throughput and instantaneous throughput. Before we were just doing average throughput. And loads of other, 2 more tests as well. So time to connected state and API response time. So both of those are really, really important. Both of those are really important. Time to connected state, what does that mean? Well, that means the time between us starting a peer connection and it actually actively going and looking for doing the ICE process, and it actually getting into a connected state. And we'll see why this is so important later. API response times. Well, there's no point, being really quick turn servers that give back relay candidates really, really quickly if your API is really, really slow. So why are API response times, going back a little bit, why are API response times important? Well, we don't just have hard-coded credentials for turn servers. We actually have to go off and get them because you want them to be one-time use. And so you go talk to an API, you get back some credentials, and then you use those credentials. So again, if starting up a session, I shouldn't say call, because WebRTC sessions can be anything. If setting that up, you've had to wait a second for a reply from an API, well, that's terrible. And we've got more locations as well. Like I say, initially it was running out of my garage, literally my garage. And now we've got 3 other locations in the USA. So Gainesville, Florida, Denver, Colorado, and one in New York as well. And yeah, instant throughput measurements. This is quite a big one. I'll show you some graphs in a minute. And another big one is we managed to get all 5 of these turn networks to give us a paid subscription. So us subscribing to every single one was going to cost us a pretty penny. And so we didn't want to do that. And originally we were using free tiers and things like that. So you start is this result bad because it was a free tier? We're not on free tiers. We've now got a paid plan from everyone. And yeah, provider analysis and feature summary at the top of the website pages as well. And we've started looking at cost analysis. Cost analysis is really, really important. I promise you, we're going to get to a live thing in a minute. Cost analysis is really important because the cost of using these turn networks is really, really different. So, for example, Twilio charge no fee whatsoever for a subscription, and you just pay per gigabyte that you've transferred. But that starts at 40 cents per gigabyte. If you send it through South America and I think Asia, it goes up to 80 cents per gigabyte. Whereas Cloudflare, on the other hand, is 5 cents per gigabyte, and it doesn't matter where. And there are other numbers for all of the other networks. They're kind of all ish similar, but ish different. All of the detail is on the website. So they're all, they've all got different pricing. So you can put those prices into a calculation, that's fine. But they all charge differently. So Cloudflare, for example, charge based off of egress to a turn client. But the way that we do our tests, we ingress from a turn client and we egress to a normal peer connection. So technically, the tests that we're running are free. So how do you put that onto a website, and how do you tell people what it would have actually cost? It's really difficult. And then our transfer numbers, we record everything. Our transfer numbers don't match theirs. So you look through their API and it says you use this much data, and I look at my API, my record in my database, and it says, no, you didn't. And it's not off by a little bit. Some of them are really off by a lot. So one of us is wrong, and I'm really hoping we're wrong. Otherwise, some of these networks are overcharging. But hopefully, we're going to help solve that problem. So yeah, who's right, us or them? Hopefully, they are right, because they're billing based off of that. And we now house all of our data in D1 from Cloudflare, which is a nice SQL-like database that you can chuck loads of data into. So let's take a look instead of me talking. So let's mirror my screen. So yes, this is iceperf.com. Let's make this bigger. Oh, that didn't make it that bigger. Do that. There we go. So we test all these different things. So we test average stun candidate latency. And so, there's no Google. Oh, I'm in Safari. And there's no Twilio logo either. Oh, okay. I should have done this in Chrome. It looks really nice in Chrome. I thought, I use Safari, I won't be cluttered, and I'll fix those later. So average stun candidate latency. So this is actually really, really, really important, because every single WebRTC session gets instantiated using stun. You want it to go over direct peer-to-peer. You don't want a server in the middle. And so this is used on every single WebRTC session, basically, keeping it simple. And so you want this to be as snappy as possible. And Google are actually fast. They're actually the fastest by a long shot. So 40. These are average numbers taken over the course of 7 days. So on average, Google are 42.8 milliseconds. And the next fastest is Cloudflare at 63.1, which is 48% slower. The numbers don't look that much of a difference, but when you start actually going, oh, that's almost 50% slower, it's quite shocking. And so, yeah, what's our slowest one? Metered is our slowest one at 105% slower. So there's a nice pretty graph that you can hover over and it tells you exactly what. So average time to connected state. So this is really important. As you can see up here, this is more important for turn, but as you can see up here, we've got 42 milliseconds to get back that candidate, which means we had an extra 20 milliseconds worth of time to start setting up that 20 milliseconds more to set up that peer connection when it's Google. But if we go down, you'll see that the time to actually set it up on average is only 1% slower on Cloudflare versus Google. You would think that gap would be a lot bigger because it had 20 milliseconds worth of head start. This is Stun, so it's a bit more relaxed. We have less control because ultimately those two peers are talking to one another directly, and it has nothing to do with that Stun server. Where it gets more interesting is these turn candidate latencies. And so you can see metered are the quickest, 103, 94, and 151 milliseconds. And so we get UDP, TCP, and TLS. And so they all support all three, other than express turn. And yeah, you can see, I won't go through all the numbers, but you can see that the next quickest is, I think, 50% slower with express turn. And Cloudflare, are really slow. Why are they really slow? And Xerxes are even slower. So it's quite interesting seeing these numbers. But then we get on to average time to connected state through turn. Right, so we had quite bad results, right? 148%, 66%, and 33% slower than metered. But on the whole, Cloudflare get you into a connected state far quicker. Okay, how does that work? Well, I'll come on to that a bit later as well. And so we do turn latency, Cloudflare win. So I can tell you why Cloudflare win, because they've got over 300 locations worldwide. And so all of these other ones have between 9 and 11. And so you're going to be really close to a Cloudflare location. You're not going to be as close to, AWS or DigitalOcean or wherever these things are hosted. Max turn throughput. So this is really interesting. For a call, we normally send, 3 megabits, 6 megabits, maybe a bit more if you're Evercast and you're sending a boatload more than that. But we wanted to test how much could we chuck through a turn server and before it said no. And we got some quite nice results. But again, I'll come on to the results of that a little bit later as well. And then average API response time. Cloudflare are actually quickest. There should be a little note underneath this table. Our API talks to their API. Where's our API hosted? It's a Cloudflare worker. And so there's like 20 milliseconds probably of savings because it's not having to go out and go to AWS or whatever. But even if we account for that, the other ones are quite a bit slower other than metered. Xerxes are taking over a second to reply on average. I wanted to show you one more thing. So that's just that's the overview. But let's go take a look at a provider-specific page. So we've got some analysis at the top to tell you why you might end up using these people, but then you can go back in time and say, right, give me the results for the past 7 days. And these aren't averaged. That number is averaged, but the graph isn't. The graph is actual results. And so you can see that the average might be 63, but that little number that you probably can't see, so the minimum is 29, and the max is 90. And again, I'll show you on a graph in a little bit why that is. So you can go in and see, how things are impacting other things. And, why are we getting things like this? Like we've got this kind of up and down that's roughly all the same, and then we've got this. Well, I can tell you why this is. We had an issue with our API, and we were only recording the results from my house for the past week, because I wrote some bad code. And so yesterday we added the other 2 locations back in. And so one of our locations is really close to Cloudflare, and I'm not. And so these are real results for every single node. And so it's going, no, my turn latency is really low. No, my turn latency is really high, So you can see it here, average turn latency, and our minimum is 3 milliseconds. Imagine being 3 milliseconds away from, one of the biggest cloud operators in the world. That's pretty cool. And the max is 32. I can tell you now, mine's, I'm adding the bad stuff because my ISP does weird stuff. So yes, that's why we've got weird looking graphs all of a sudden. So yes, you can go take a look at all of this as well. I fixed this. Look, 100, oh no, maybe that is 1. No, that should have a little, anyway. I love finding things that are broken when I'm up on stage. So turn throughput, so this one. So these solid lines are our average throughput through the whole session. And that's why we get a nice curvy line. When we launched at JanusCon, oh crap, I've got 2 minutes left. When we launched at JanusCon, that line was not a nice curve in that direction. It was actually a curve up and then terrible. And we managed to get the Cloudflare team some data, and they fixed it. And the thinner lines are now instantaneous throughput. And so that's where we can start seeing higher maxes. So I should probably finish my talk if I've only got 2 minutes left. So some interesting things that weren't on the website, and this is where I kind of tell you about some of these oddities. So yeah, my home broadband upload sucks. And so these are a test from the person that is 3 milliseconds away from a Cloudflare location. And they've got gig up and they've got gig down. I've only got 100 meg up. And so they were testing Cloudflare for me, and they can get a max throughput of 273 megabits per second, which chucking that through, a turn server is pretty damn cool. This is using, public API keys and everything. You can go and chuck data at this rate through Cloudflare. I don't know about the other ones because I haven't tested them because my broadband sucks. So if someone wants to sponsor a new broadband connection for me, that would be great. So max turn throughput. So what are these graphs? Why did I arrow things? So this is actually where we changed how much data we send through. We now send 4 megabit blocks through the data channel to test it, and we used to send 1 megabit blocks. So this is us. This is us changing that, and then the second one is where we look at instantaneous throughput number instead of the average throughput number, and so we end up with a bigger number. Average stunned candidate latency. What's going on here? So you'll see this didn't happen in the live website because this node is currently not public for this reason. This is not public because this is a router in New York that has an IPv6 tunnel through electric tunnel, or whatever they're called. Electric hurricane, thank you very much. And this is what happened to our nice, pretty graphs. They went from, minimums of 30 milliseconds or whatever it was, up to like it taking 2 seconds to get a candidate. So that node is currently collecting information, but we're not displaying it. I think it's really interesting how, having that tunnel is impacting getting candidates. And I think this is from yesterday, where we added in those extra 2 nodes again, and then you can start seeing how that impacted the results. And so you can see I think this is from Cloudflare, so we were sitting at around 400 milliseconds, but as soon as you add in that node that's really close to Cloudflare, that average comes back down. And yeah, sorry, Rel. Their graphs were really low until I added in nodes in America. And their turn server is in Germany, I think. And so they're not a globally distributed system. And so it ends up looking really bad on graphs. But that's a separate thing because we haven't properly started looking at projects. So are we done? No. Next feature is accounts. So adding in public nodes, signing up for public nodes, but also subscriptions for testing your internal turn networks. And very, very quickly, so average for stun was 42.7 milliseconds. But yeah, Cloudflare gets really quite low if you're close to them. And yeah, that thing about connected state that I was talking about. Metered is really quick for offering relay candidates, but Cloudflare wins when you actually want to get a connection. So they're 152%, 69%, and 36% slower than metered, but they're quicker in actually getting you into a connected state. And that's because Cloudflare is usually the closest. So yeah, 22, 24, 25 milliseconds is the average, but you can be as low as 3 milliseconds. And yeah, finally waiting on 500 milliseconds or 1 second for an API response isn't great. Which one's best? Cloudflare win out of 8 out of 15 tests so far today. So is Cloudflare the best? Twilio still have loads of IP addresses in corporate firewall, and that's where you actually want to, get in. So is Twilio the best? And yeah, finally, if you've got an open source project, turn server project, get in touch because we want to test them. Thank you very much. And if you want this t-shirt, then you can go on shop.everycastlabs.uk and we ship worldwide. And that really is me. Thank you very much.
Are there any questions?
I'm sorry I went over.
Is there room for more providers, and are there services that aren't being delivered by these guys in terms of bandwidth or distribution or whatever that you're like, there really should be another provider that does X?
I don't want to sound too kind of pro Cloudflare. I usually have a thing in there that says, I have Cloudflare shares. So I have Cloudflare shares, but it's not really the reason why I'm saying this. Until Cloudflare entered the mix, I would say yeah. But now that Cloudflare have entered the mix, they've got 300 locations worldwide, or over that, but they're not in China. The turn server isn't in China. And they're very active in wanting to push their service even further. So I'd love to see more competition, but how can it, like Subspace tried to do it a couple of years ago, doing very similar stuff to Cloudflare, and they failed, because they didn't already have all of the infrastructure. So I'd find it difficult to go, oh, someone else can do something better.
Hi, great talk, Tamas from S7MP. My question is there a way to run iceperf on my own network? Like running, is it available like an open source stuff that I can just run on my laptop and test it?
Yes, absolutely, thank you. So yes, the iceperf agent is on the GitHub, on the NimbleApe GitHub. So github.com/NimbleApe/iceperf-agent. Come up, I'll yeah.
Sure.
There's a config file, so you don't even have to talk to our API. You can just say, here's a config file, and go test my turn server.
Perfect.
You can do whatever you want.
That's great. Okay, thanks.
Any other questions?
Boris over there, I think.
So for time to connected state with stun, where are the endpoints and how do they connect?
So the two endpoints are right next to each other, but they don't get told about each other's host candidates. They only get told about their server reflexive candidates. The test doesn't actually work on my home network. It fails. I can go get the candidates fine, but the peer connections never make it into a connected state in my network. I don't know why. It's something to do with, NAT loop backing or something. But it does work in other networks. And it technically goes out and then kind of back in. So yeah, it's a weird test that I need to explore more to figure out, A, why my test doesn't work at my location, but it works elsewhere. Yeah, it's a bit of a weird test, but it's meant to kind of give a nice, meant to give a nice initial number to compare the turn numbers against, because that's what we're really testing, the turn stuff.
Thank you.
There is one more question.
Since the network travel time is such a big contributor to some of the tests, did you consider compensating for that, just subtracting the ping duration?
Not really. It's a good question. Ultimately, I want to get to a point where we have loads of nodes doing these tests, at which point they all kind of, the average evens itself out. And you can already see that happening when we've got the 3 nodes that we look at. As soon as you add in other people's nodes, averages drop because versus my connection and whatever. If I started removing stuff, it feels like there's room for error. If my ISP overnight changed things, yeah, I could go and do a ping. It's just easier to say, these are the numbers. They're not meant to be absolute. And these are what real devices are gonna get. We do record the ISP against the node, so we know exactly where that traffic is coming from. And so a mode in the website that we want to build once we've got a few more nodes is being able to say, right, go and show me the data for Virgin Media, which is my ISP. Go show me, Cox in the US or whatever. We can be more transparent with our numbers, but I wouldn't want to change the numbers.
Final question from Boris.
Have you considered using something like Thousand Eyes or something else to have a lot more endpoints to test from?
That's a good question. Yes is the short answer. We were looking at stuff, being able to kind of run these tests. Well, we want to create these tests in loads of different languages as well, because these are just testing Python today. Python might be really bad at doing, turn, I don't know, handling turn candidates. So we want to test lots of other languages, which then opens us up for being able to do, Thousand Eyes or, the little boxes that you run programs on that everyone's got in their homes, etc. So yes is the short answer. We're just not there yet.
All right, I think we've got it. Thank you very much, Dan.
Thank you.